Alright, so this is about interior and exterior angles of polygons, and this first part A is a classic. The interior angle is 175, so when we draw our picture, we're looking at the interior angle being 175. Now, importantly, that means that the exterior angle, if we were walking on a straight line around the edge of the shape, and we decided to carry on and kept walking in a straight line direction, you could see that actually this exterior angle is 5 degrees, and then we'd have to turn 5 degrees this way. Now, when we get all the way around to the start again and facing the same way, we have gone through 360 degrees in total. So if we divide 360 by the 5 degrees, we see how many times we need to turn. And you can see that that would be 72. So there are 72 sides in this polygon, regular sided polygon. And the part B here, we just make sure that we've got all information from the words transcribed to the picture. So do we have BA? BA is here. Is it marked on that it equals to BD? And that it equals to BC? Yeah, I mean, they've been marked on, the length's the same. So that might help with some isosceles triangles, right? If they're isosceles triangles, we know the base angles are equal. Let's see now if we've got DAB is 74. DAB 74 is here, yep. ABD is X. A to B to D is X, yep, that's marked on. DBC is 2X. DBC is 2X, yep. And BCD is Y, BCD is Y, yep, great. So all of this information is already marked on the diagram, so that's great. So let's go ahead and just fill in some pieces that we know. So I think the first thing I'm going to do is look at isosceles triangles, and I'm going to look at this triangle first, right, DBA or ABD, and I can see that the base angles here are equal because of the isosceles triangle. So I'm going to put a 74 here. And now I'm going to look at this top triangle because, again, I see another isosceles triangle. This isosceles triangle here means that these two angles are the same. So the Y here must also be the Y here. So let's go and put Y. There we go. And let's see, what else have we got? Yeah, well, I think we've got enough information now to find out lots of different things, right? Because if we go back to that first triangle now, down here, there's only one missing angle, right? So the X here must make all of these add up to 180. So we'll find X first. X is 180 minus 74 minus 74. Okay, so X I think is, what's that, 148, X equals 32 degrees. So there's 32 here. That would make the 2x here 64. And we can see now that for angle Y, 180 minus the 64, that is equal to 116. So 116 degrees has to be split equally between the Y and the Y. So we divide by 2. 116 divided by 2 is the 58 degrees. All right, so once we've got those angles in here, we can actually put 58 now in this place, and we can put a 58 in this place. And then let's have a look at the last question. Explain why AD is not parallel to BC. So they're saying that explain why these two lines are not parallel. And I suppose one of the answers could be if we consider this transversal. If they were parallel, then this angle plus this angle would be called co-interior angles, and they would add up to 180. And so we could say that angle DAB plus angle ABC should equal to 180 if parallel. However, we can see that 74 plus the 32 plus 64, when you actually do this, it does not equal to 180. All right, you can have a quick check. You can see that 60, 70, 80, 96, this is actually 170 on this side. Okay, and so therefore they are not parallel lines. So we have to have some kind of reasoning about the parallel sides there.